Hello, everybody. Welcome to our Embedded Systems Week 2022 event of the Test of Time Award. My name is Jürgen Teich. I'm with the University of Erlangen-Nuremberg, and it's my great pleasure to guide you through this award ceremony. First, some words. Embedded Systems Week 22 proudly presents for the fourth time now in recognition of a paper with highest impact previously presented at Embedded Systems Week, the so-called Test of Time Award. I'd also like to welcome at this point of time the technical program chairs of our three major conferences, which is for CODES plus ISSS, Chengmo Yang and Mohamed Al Farouk. Welcome for EMSoft, David Broman and Claire Paghetti. And for cases, Preeti Panda and Swarup Bunya. Let me give as a foreword how this award is basically formed and created. First of all, each conference chairs, they have to come up with a selection of 10 candidates, which happens typically by end of April. Then they determine an independent award committee of 3 persons in May. With the committee, they discuss and reduce their 10 candidates, potential candidates, to just 5, with some argumentation why these are most impact papers through the years. And finally, there's a discussion round and the winner nominated typically middle of June. You saw Embedded Systems Week celebrates its 18th conference year. Of course, some conferences like cases started already prior to this. However, we honor, since the common event Embedded Systems Week merged together this, and we have a gradual time window, which is currently for cases 2004 to 2007. For EMSoft, it's 1 year later, 2005 to 2007 was the selection year, and for CODES finally was 2005, also 2007. Up from 23 on, we have the moving window will be papers selected from the period of 2006 to 2008, and this will continue hopefully throughout the forthcoming years. Now we come to the winners, and it's my great pleasure to start with the first award. In alphabetic order will be the award that has been selected as the Test of Time Award 22 for cases. And this paper is titled Scalable Custom Instructions Identification for Instruction Set Extendable Processors. And you might know, if you have been attending Embedded Systems Week so long, or you studied these excellent papers before, it's given by the authors Pan Yu and Tulika Mitra from the National University of Singapore in Singapore. And it came from the year 2004 of cases. Congratulations to Pan Yu and Tulika Mitra. So Tulika, do you want to please address a few words on this paper? How did you plan to become a Test of Time Award? What it is about, really, what should we learn from it? And how do you think it has created impact also for now and the future?
Thank you, Jürgen, and thank you to the selection committee for this recognition. Panu and I are truly honored to receive this award. I must say, when Jürgen approached me, it was a really nice surprise. I worked with Jürgen and Petru. I very well remember to introduce the first Test of Time Award in New York City in 2019, and that was our last physical in-person meeting. And I remember the excitement and the buzz. Never did I think that we would be the one to receive the award one day. So thank you, thanks a lot. This paper actually brings back many fond memories for me. I was a junior faculty starting my independent research at that time. And Panu here was my first sole PhD student. So it's a very special bond, and we work very closely together. I became quite intrigued with the idea of custom instruction set extensions They were a great match for embedded systems as they allowed acceleration for a specific application domain through the custom instructions. And they were quite hot in early 2000, with Tensilica being one of the main industry players that were pushing the technology. It got acquired by Cadence later on. The challenge, however, was how do you really identify these custom instructions? And there were some heuristic solutions, but we were really looking for an exact solution. Turns out that while we were thinking about this problem, Laura Puzzi and Paulo Iene from EPFL wrote a paper on exactly the same topic in DAC in 2003. And guess what? They actually got the Best Paper Award for that work. And I really loved that paper. I thought it was very elegant and it was a clear algorithm. It was also very easy to understand. But at the same time, we felt that that algorithm was very combinatorial in nature and it was not exploiting all the things that you could exploit to make it much more efficient. So instead, we kind of took a very different approach and we exploited the structure of the data flow graph from which we were trying to identify the custom instructions. And we kind of exploited all the constraints that were imposed by the architecture. And because of that, our algorithm was very efficient and it was very flexible and the results were quite impressive. I remember we took less than 0.1 second to solve some of the problems that were taking 1 hour by the previous algorithm. So that part was fun and that was quite nice, but what was really challenging for us is to write the paper. It took us quite a while to figure out how to explain the algorithm in a more accessible way and bring out the intuition and the proofs. And I think I drove Panu quite crazy with that. Even in the end, I think I was not quite happy with the way we finally wrote it. But I think his thesis in the end, after 2 years, was much better than what is there in the paper. Anyway, I think from that point on, there was quite a healthy competition between the EPFL group and ours to improve the algorithm, and we kind of made it better and better. What was really nice about that was that through the process, we also became very good friends and we remained so. So that was really happy times. So what happened to custom instructions? 20 years down the line, right? This paper was 2004. Actually, there was quite an active community around customization at that. Okay, so yeah, so there was quite an active community around customization at that point in time. It included Nick Dutt and Sri Parameshwaran, York Henkel, Scott Malke, Jason Kong. There were many people involved there. However, in the main, sorry, I think there is a echo. Okay. Yeah, but in the mainstream architecture community, I think general.
Andy, is your mic open? Okay. Now everyone is muted except for you, Tulika.
Okay, then I'm not quite okay. Anyway, I think there was the general purpose processors in the mainstream architecture research community. They felt that there was no need for customization. But as with many things, I strongly believe that embedded systems are kind of harbingers of many trends because we kind of face all the challenges early on. And in this particular case, this is a classic example where we fast forward 20 years and domain-specific accelerators have become all the rage. And more to the point, I think the recent RISC-V custom instruction set extensions today that you see everybody is talking about really brings it back all to where it started. So this has been a really interesting journey. So with that, I thank you again and look forward to contribute to the community in the future. Thank you.
Thank you very much, Tulika. So maybe just one question, as you mentioned also novel instruction set processor architectures like RISC-V. Is there any potential for a need for additional research here, or you think with your papers and Paulo's and your work, most of the basic problems are solved and it's just a new hype for other processors, or are you yourself also continuing in that direction?
Yeah, Jürgen, thanks for that question. I think it's an interesting times. I think the algorithms by themselves probably matured quite a bit, that one can actually use them pretty much. In fact, many of those are coming back in a way in the context of RISC-V. But I think the scope has changed. So we are looking at, and your group is also looking at that, right? Both fine-grained as well as more coarse-grained acceleration, right? In terms of the accelerators. So that's where I think there is quite a bit of scope in finding out where the sweet spot is with respect to different applications and domains. So that's kind of interesting time.
Thank you, Tulika. Other questions here from the group or also from outside? If not, then let's congratulate Panyu and Tulika Mitra one more time for this wonderful award. All right, I would like to advance now to our second major conference, which is CODES plus ISS. Also here, the committee had a difficult time to filter out from a great selection of high impact papers according to citations, to recognition, and to the impact of the contents, of course. And I'm glad to announce that the final winner of CODES plus ISS is a paper from CODES plus ISS 2007, which has the title A Framework for Rapid System-Level Exploration, Synthesis, and Programming of Multimedia MPSOCs. And the authors are Mark Thompson, Risto Nikolov, Todor Stefanov, Andy Pimentel, Chakan Erbas, Simon Polstra, and Ed de Pretere from University of Amsterdam and Leiden University, the Netherlands. Congratulations to all of you for the Test of Time Award for CODES. And the paper stemmed from, as I mentioned already, 2007 publication. Congratulations. I'd like to give the word to author Ed de Pretere to say a few words about how this great work came into being and the cooperation maybe between the two universities and what is the content of your paper about.
Yeah, thank you, Jürgen. I think I want to say a bit about the history of the system. The details can be found in that paper that's shown here. So the origin of the Daedalus framework dates back to the year 2004, when work on key features and tools took off. The year 2006 may be considered the birth year of the Daedalus system. A full rough version of the system, including test results, was published and presented in 2007 at the 5th CODES plus IIS conference, followed by an invited presentation and paper in 2008 at the 45th ACM IEEE International Design Conference. It is my pleasure also to thank the whole Daedalus crew, in particular Professor Andy Pimentel from the University of Amsterdam, Professor Todor Stefanov from the University of Leiden, and Dr. Hristo Nikolov, who was at that time at the University of Leiden as well. To help proliferate the Daedalus framework system, the Daedalus Foundation was established in 2009. In the period 2010-2011, the foundation sponsored the development of a user-friendly version of the system, including a mapping graphics user interface that would help system designers, engineers, and students to easily use the tools constituting the framework. And in addition to that, Daedalus has been extended with new advanced techniques and tools for designing hard real-time embedded streaming systems. Now, the name of the framework, Daedalus, was taken from the ancient Greek mythology. Daedalus was a great inventor, architect, and sculptor, living in Athens together with his young son Icarus. King Minos of the Greek island Crete invited Daedalus to construct a labyrinth from which no one would be able to escape. He locked in that maze a monster that was living on the island of Crete, a half man, half beast, and a friend of the princess of Crete was able to slay the monster with the help of Daedalus. Because that, the king lost his trust in Daedalus and imprisoned him in a tower on the island. He could not escape by sea because it was strictly guarded. The only path home was the air. He built wings of wax and feathers for him and his son. Daedalus warned Icarus not to fly too high because the heat of the sun would melt his wax. And so not too close to the sea water because it would make the wings wet. In both cases, he would not be able to fly. The father and son took off in the air. However, Icarus was so exalted by the ability of flying that he started to drift up and away from his father, ignoring all the warnings. The shining sun melted the rocks and the Icarus fell down and drowned in the sea. The analogy here is that the Daedalus framework made electronic system level design takeoff possible. However, the framework is based on several assumptions and has limitations. Therefore, the assumptions and limitations need to be well understood and respected in order to avoid falling into the sea. That's the study.
Thank you very much, Ed. I think this gives a very nice explanation that this paper seemed to basically tame the beast in this Greek myth, and I think it really did, I guess, no topics other than system level design space exploration, synthesis, and multimedia and MP-SOCs are still a topic not only of 2007 but still in its fancy today, and many papers come out, as we see, in this area still on a hot topic you envisioned already at that time being very important to solve. So congratulations to all co-authors here, and we are also, if you will, ready for a few other questions here to the group. Yeah, maybe one. Do you still cooperate between University of Amsterdam and Leiden?
Yeah, I think we do. I think we do.
Yeah. And Ed, you are emeritus now, and Todor is it correct? He is your official successor of your.
He's my successor. Yes, he is.
Yeah. Okay, so there's still also continuation from the antiques now, the Greek. Now to the presence in this regard, and that's great to hear. Maybe Andy wants to also comment.
Yeah,
here.
so we are still very active in co-developing tools together. So Leiden University in Amsterdam. So there's more to come for sure in the coming years. Working on all kinds of stuff, exciting stuff.
I know. Okay. So other comments, questions to the group. Okay, so Hristo Nikolov, he is also professor, has become a professor, or Hristo, you're here?
No, unfortunately, I drifted from the academia and moved back to the industry.
Okay, but in the Netherlands, or can you say where your current occupation?
Yeah, currently I'm a R&D manager at Honeywell, the Netherlands.
In the Netherlands still.
In the
right.
Netherlands, yeah, developing embedded systems. And I must say that I'm very grateful for the research I've done during my PhD study, because for some of the projects we do really need some innovative thinking. And I must say, in one of the projects, I should not disclose everything, but in one of the projects I applied some of the process network principles in a real-time operating system. It was very very pleasant experience, I must say.
Well, that's also great to hear. So the paper has generated not only academic impact, but also impact in being applied in real industrial relevant applications.
Definitely, the potential is huge. Yes.
Yeah. All right. So if there are no more comments, then let's clap hands again to this CODES plus ISS Test of Time Award paper. And I'd like to advance now to the third conference, which you all know is MSoft. MSoft has also a similar tradition of 18 years being one of the major 3 conferences in our Embedded Systems Week portfolio. And also here, the program chairs elected a committee which also proposed a very interesting paper. And the winner of MSoft 22 is a paper from MSoft 2006. And the title is Real-Time Interfaces for Composing Real-Time Systems. And the authors are Lothar Thiele, Ernesto Wandeler, and Nikolai Stoimenov from ETH Zurich. At least at that time, all 3 authors have been at ETH Zurich. And the paper was, as I mentioned, from MSoft 2006. And it's my pleasure to introduce Professor Dr. Lothar Thiele, who will be receiving the award. Congratulations to all authors for this paper. So I quit now my presentation, as I heard Lothar will tell us more in a short presentation himself about this paper.
Okay, so at first, thanks a lot for the introduction, and of course for choosing this paper from 2006. And actually, it's a long time ago, 16 years, and I need to say it's the first time ever that I read an old paper from this time again, right? At least one of your own papers, right? Of course, you read a lot of papers from others, also from this time, but really rarely your own paper. And in this sense, I brought a surprise. I even found the original presentation, and I will not show it in every detail, but just two slides of it. In order to explain a bit what the paper was about. And I think this was actually the first slide of the presentation at that time. So it was dealing with real-time systems, event streams, resource interaction, and at that time, many people dealt with components and interfaces and abstractions. And the question was how to analyze a complex distributed embedded system in terms of real-time properties by putting components together. And the second question is how to build these systems from subsystems while meeting requirements. Okay. And as I mentioned, it's mainly dealing with real-time systems composed of processors, buses, communication links, and the like. So during this time, as I also mentioned already, many people dealt with component-based analysis and synthesis. It got lots of attention. And therefore, we have, of course, not the only ones trying to understand how one can analyze and synthesize large systems. And the analogy was somehow, as you see on the integrated circuit, that these techniques exist for digital design, for example, but not for something related to real-time properties. And from the, I also looked out at the citations, and one can see that there are quite some other research groups, of course, doing the research, and all the names sounded very familiar to me, and you also, in Supli, Arvind Eswaran, Arvid Benveniste, Rajiv Allur, Tom Hensinger. These are just a few people working in this context. So just for a few words, what are the main, so the last slide, the main things that have been done, so that you have a little bit of understanding what happened. I think one thing was how to compose subsystems in a distributed systems and try to understand what are then the end-to-end properties. And this was known already, and there are many concepts from real-time systems, and one that we used in the paper was called real-time calculus in order to use this for abstractions. But the paper showed a little bit more. It showed something that was called refinement. I just read a newspaper article from Toyota. They try to now in the new cars to replace the electronic systems by newer ones, right? So that you have an upgradable car. And this is somehow the question. Now you replace one of these components by a new one, and does the system still work? This was called refinement. And then there were some theorems in what cases this actually was true in terms of real-time property. Now the next part was, let's say, I think a little bit more interesting in this sense. I think, what does adaptivity mean? Suppose that we have a distributed system, including, as I mentioned, computations and communication. Analysis would mean, given the inputs, given the processor capabilities, the connection between all of these components, networking properties, what kind of deadlines can we guarantee? That's a typical question. Now, in interface-based design, as proposed in the paper, we use constraint propagation. And the question is different. Given requirements and constraints, like end-to-end deadline, what are the assumptions towards the environment, like input rates, burstiness, processor capabilities, packet size, and so on, so that these constraints are satisfied? And this is synthesis, automatically determining all these parameters. And this could be done actually online during the operation of the system. So that online, adaptively, you can change things, and then still the system satisfies its properties. Of course, quite some mathematics was involved in order to enable this, but this was the main result of it. So now the last question somehow would be, would I recommend someone nowadays to read the paper? Right? That's a good question. And I think the focus in the area moved, right? There is not so much anymore in terms of component-based systems, but at least also in our research, the underlying concepts to have components, to let them interact and adaptively change the properties has been extremely useful. For example, in wireless networks, you have lots of nodes. They try to use the wireless network. It has a limited capacity, and now constraints change, and you would like to know, does the system still work? What are the limits by how much you can change them? And all of this should work adaptively. And this is what we and others also did in the area of scheduling distributed wireless systems. And these components are then actually implemented in software and running on them. Okay, so this is what I wanted to say. Well, finally, of course, thanks to my co-authors, Nikolai Stoimanov and Ernesto Wandler. They were PhD students at that time. And especially thanks also to Ed, okay, because we had great events in Leiden where we discussed all of these things intensively, and analysis, composable analysis, comparing various methods, the important and well-known Leiden workshops. So I remember very much this time. Okay, so then thanks again for choosing the paper. And this is what I wanted to say.
Thank you very much, Lothar. And we are advancing in time now. We have now a next keynote that I guess Ariaval will announce what comes next in our program. I would like to thank especially and congratulate one more time all winners of the Test of Time Award. You will receive a certificate, and also from IEEE Computer Science Press one plaque with a golden plate on it to recognize your paper. And please enjoy also the rest of the conference. It was a pleasure to host you through this awards session. Thank you very much for attending, everybody.
Okay, before you go, let's take a picture, actually. So it's in this full screen mode. Okay, all cheese. Thank you. And congratulations, everyone, once again. Just to remind everyone, this Test of Time Award is really the highest honor that these 3 conferences confer. And these are given to papers that have really stood the test of time in every way. So this is a really big achievement for the community and the authors. Thank you. Now let's